Good morning, folks. It's me again, Mr. Tuttle. Down here, hydrating with some berry flavored LaCroix because it's not good to just drink coffee all day. You also have to get some actual fluids. And so, but I'm also here not just to hydrate, I'm also here to talk about that football video, which I thought was pretty amazing. I hope you thought it was cool. I hope you thought it was a fun assignment. I know it sounds like I say this about all of my assignments, but that's one of my favorite assignments of all time. And so I hope you enjoyed it too. So I haven't yet dug into your answers to those. That's what I'm going to be doing later this afternoon and tomorrow. But now that kind of the dust has settled around it, some of you are starting to ask and wonder, how did you do that? How did you do that? Was it real? How many helicopters do you own? Can you please put on some shoes? How many footballs do you own? Are you truly a professional quarterback disguised as a physics teacher? I'm here to answer all of your questions. So let's recall what happened. So it was a pleasant. Actually, it was evening. I had just eaten dinner, and I decided I better start getting ready for physics. And I decided to. I had seen this video of a young person years ago throwing a football about 40 yards and catching it, like legit. And the same question, like I was like, so for the last few years, I've shown my students that video, and I've asked them, is it real or not? They go through the whole thing. This year, I thought, wouldn't it be fun if I just tried it myself? It turns out I'm pretty good at it, right? So let's analyze what happened. What happened? So here is what happened. Um, Here's me. That right there is my daughter who's taking the video. And here's the football. And I said, on the count of three, I'm going to throw this ball. 1, 2, 3, and it went. And meanwhile, I'm running, and I catch the ball, and I go. I was like really excited, so I was like, woo! I danced a little bit, and that was it, right? So, what do we know about this situation? Well, one thing we know is that this is not a very well drawn trajectory. We know that the trajectory of that ball is parabolic, virtually perfectly parabolic. It wasn't a very windy day, so it has that sort of, that arch, that symmetric arch. So even though my picture isn't perfect, it'll do. Okay, we know that that's the highest point. Okay, we know that this was about 30 yards. Let's see. Hey Siri, how many meters are in 30 yards?
30 yards is 27.43 meters.
Thank you. So we'll call it 28. So we'll say the distance that I covered horizontally was 28 meters. And there really wasn't much else for you to collect in terms of data from the video aside from the most important thing, kind of the key to this whole thing, is how long was that ball in the air for? Time in air. Okay, and I think most people, and I agree because I looked at it a couple times, that time in the air was about 8 seconds. We'll call it 8 seconds. If we're off by a tenth a second here or there, I don't think that makes that big of a difference. Okay. So if it's in the air for 8 seconds from here to here, that means its highest point is at t equals 4 seconds, right? Okay, big deal, right? But the other thing we know is at its highest point, vertical velocity equals 0. Because what's happening is as it goes up, okay, velocity is positive, but acceleration due to gravity is negative, right? It's kind of pulling it downwards. It's decreasing that velocity all the way until it gets to its highest point, at which point the vertical velocity is 0, and then acceleration continues to do its thing. Gravity continues to do its thing and accelerates it downward turning that velocity negative. Okay, and then I catch the ball, right? So, we know that the ball must have had some initial vertical velocity, and we know that the ball must have had some initial horizontal velocity. So that's VH and VV, right? VH, whatever it started with, stays the same. That VH is constant. So we can just knock this out real quick. For horizontal, the velocity horizontal is equal to distance divided by time, 28 meters divided by 8 seconds, which if I just, it's like 3 or 4 or something. 28 divided by 8, 3.5. Oh, okay, that's cool. So, horizontal velocity is 3.5 meters per second. That doesn't seem unreasonable at all. I know I can run 3.5 meters per second. I can run faster than that, probably. Okay, so we'll put that aside, and now let's think about the vertical velocity, which is the more interesting one. So if the change in velocity from here to here was, whatever the initial velocity was to 0, let's see, acceleration is 9.8 meters per second, and the time is 8. So the change in velocity vertically, oh boy, 9.8 times 8, 78.4 meters per second. Okay. Wait, no. I was going to say, that's crazy. It didn't do that for 8 seconds. It did it for 4 seconds. Because it's only, you're right, we're talking about from here to here, that's only 4 seconds. I was like, there's no way, 78.4, that's ridiculous. Okay, so what does that come out to? That comes out to 9.8 times 4, 39.2. Doesn't seem that bad. 39.2 meters per second. Okay, so that's what I've got. I've got a vertical initial velocity, a horizontal initial velocity. What I can do next is I can figure out the overall velocity by doing a little bit of Pythagorean theorem stuff. Sorry, these notes are a little bit messy, but trying to keep it organized. We have, that's 39.2, that's 3.5. The overall velocity squared will be 39.2 squared plus 3.5 squared. What does this come out to? It's going to be right around 40. 30, I'm going to need this one. Clear. 39.2, no, 39.2 squared plus parentheses 3.5 squared parentheses equals that, and the square root of that, okay, yeah, 39.4. 39.4, so overall equals 39.4 meters per second. Now, we, in this part of the world, maybe aren't super familiar with, it's not intuitive. 39.4 meters per second, it's like, how fast is that? I don't know. If you tell me miles per hour, then I can get a better sense of if this is reasonable or not. So you know who I'm going to ask. Hey Siri. Hey Siri. How many miles per hour is 40 meters per second?
40 meters per second is 89.48 miles per hour.
What? 89 miles per hour? Okay. That's not too bad. Because I watch baseball. I watch Major League. I used to play baseball. I wasn't a pitcher, but I know it's not uncommon at all for even like really good high school baseball players or college baseball players to be able to throw a baseball 100. So maybe this isn't that bad, um, or maybe it is because a baseball is not a football. And one of you actually asked, how heavy is the ball, which is important. Okay, we'll talk about where the implications of mass in a situation like this when we talk about momentum and impulse and stuff. But if you look it up, kind of like the world record for the speed of a football is more like 60 miles an hour. So I mean, there you go, folks. Now I know you're maybe wondering like okay, how'd you do the video then? You don't look like you don't seem like you're great at like your videos are great, but they don't look very well edited. Like I don't think you have the capability to like Photoshop whatever. So how did I do it? I'll tell you this. It doesn't involve a helicopter. Maybe what I'll do is I'll later on this weekend I'll post a behind the scenes video that shows how I did it. But for now, yeah, if you said there's no possible way Mr. Tuttle did that, this is totally fake, you are right. How did I fake it? I'll tell you. So what I did was